Good afternoon, students. Today I am discussing about the mutual induction. What is mutual induction and what happens in that process? At first, we have to know what is due to this mutual induction. We have to know what is primary coil and what is secondary coil. Now, if we take two coil, current carrying conductor turn some current carrying conductor and take that coil, like this is primary coil and this is secondary coil. How we can rename that primary coil and this is secondary coil? At first we have to understand. First we take two coils and connect a coil with a battery and another coil with a galvanometer. Now, due to connection with battery, some current passes through this coil. So, as some current passes through this coil, that means it becomes a current carrying conductor, and due to this current carrying conductor, it induces some magnetic effect around itself, and that's why which coil is connected with battery is called primary coil, and which coil is connected with galvanometer to find or to measure the current, if current flows through this coil or not, that is called secondary coil. Clear? Now if we connect a battery with this primary coil, first coil, some current flows. Now as we connect this battery with positive terminal in that end, so we can say that the current will flowing through this in that direction and flowing towards downward in that part of that coil and reaches at that point. So if current passes through this coil, so due to current carrying conductor, current flows through this coil, so there is a magnetic field created around itself, and using Oersted law and Fleming's left hand rule, or otherwise we can use the right hand thumb rule also, the current is flowing in that direction and move in that direction. So your thumb is showing the north pole of the induced magnetic field. So it behaves like a electromagnet as current flowing through this coil, and the north pole of this magnet is towards this direction, becomes north pole, and towards this direction becomes south pole of that coil. So we can draw the magnetic lines, field lines for that electromagnetic field, for that electromagnet. So we can draw the magnetic field lines which becomes from the south to north inside the electromagnet, and outside it will emit from the north pole and enter at the south pole. So if we draw the magnetic field lines, it looks like, if we draw with the red pen, we can show you, I can show you this magnetic field lines looks like this. Like that. So magnetic field passes from this, as we connect a battery with this coil and some current flows through this coil, so it becomes a electromagnet, and we can draw the magnetic field lines due to this electromagnet, and this magnetic field lines enters from the south pole and emits or exits from the north pole inside this coil towards this direction. So due to these magnetic field lines which passes through this second coil also, so if we change this number of magnetic field lines, then if we change the magnetic field lines in that first coil or primary coil, then using Faraday's law, their magnetic flux also be changed in that secondary coil. If we change the current, if we use a rheostat, this is the rheostat here, this is the rheostat here. So if we use a rheostat and change the resistance here, so current also be changes. If we rename the current as I, so current in that primary coil will be changed. So as current changes, then it number of field lines per unit length also be changes. So magnetic flux also changes. So we can say that if current flows, then there have some induced EMF. If current flows through this first primary coil, then it creates some magnetic field lines or magnetic fields using this solenoid formula B equal to mu 0 Ni. So as change in current is possible, so magnetic field lines also changes, and that's why in the secondary coil, there will be changes in the magnetic flux. What is magnetic flux? We already know that. Magnetic flux means number of field lines passes through a unit area. So if we change these magnetic fields for this primary coil by changing the current, so the magnetic flux in the secondary coil also changes. So as magnetic flux through the secondary coil changes, so it generates an EMF, it induces an EMF to the two terminal of that coil. So as if we connect this coil with and close this coil with a galvanometer, then some current flows through this coil. So due to this flow of current through the primary coil, there is an induced current in secondary coil, and galvanometer shows the deflection. So and this process is called mutual induction. Mutual induction means, what is the mutual induction? The process in which changing the current in the primary coil, if we change the current in the primary coil, then induces an EMF in the secondary coil. Some EMF is induced in the secondary coil due to change in magnetic flux. That is called mutual induction. Clear? Now what is induced EMF? If we change this, how many times and how fast we change the current here, that time it change the magnetic flux, and as well as mutual induction also be happens, and induced EMF also be happen this time and this first process. So we can say that magnitude of the induced EMF in the secondary coil, magnitude of the induced EMF in that secondary coil is directly proportional to the rate of change of current in the primary coil. How fast we change the current in the primary coil, that time the magnetic flux also changes, so induced EMF also be changes. So we can say, if we write the induced EMF in the secondary coil as E of S, so magnitude of the induced EMF in the secondary coil is directly proportional to the rate of change of current. Rate of change of current means with respect to time, change of current with respect to time. So rate of change of current in the primary coil. Clear? So for that proportional equation, if we equate this, we can write induced EMF in the secondary coil is equal to a constant into rate of change of current in the primary coil, and this constant is called mutual inductance. The process is called mutual induction, and this constant M is called mutual inductance. And we write a negative sign also here. Why we write negative sign? Because following the Lenz's law. Lenz's law states that it opposes the current, induced current is in that direction which opposes the creation of the current, which opposes the cause of the creation of the current, and that's why we write this negative sign. Clear? So what is mutual induction and what is mutual inductance, we already know. And another thing we have to know, that is mutual inductance. We can write this value here. We know that the mutual inductance equal to induced EMF in the secondary coil divided by rate of change of current in the primary coil. So we can write mutual inductance equal to minus of induced EMF in the secondary coil divided by rate of change of current in the primary coil. So the SI unit, when we find the SI unit of mutual inductance, we can write the unit of the induced EMF is volt, induced of the current, in the flowing current in the primary coil is ampere and time is second, so ampere per second here and volt is here, so volt into second divided by ampere. So in unit of the mutual inductance is volt into second per ampere, and we name that unit as Henry. We write it symbolically at capital H. What is 1 Henry? That is the unit of SI unit of mutual inductance. Now 1 Henry defines as when current changing in, now look here, if